Okay, well, hi everyone. So today is Christmas Day in 250A because we're going to start looking at your kits. So before we start, do you all have your kits, or is there someone here who actually doesn't have a kit yet?
I verified that everybody should have their kit now.
Okay, awesome. That is perfect. Cool. So I'm gonna start by just giving you a very quick tour of what's in the kit, and then after that, I will try to give you a soldering tutorial, and of course it will be recorded. So when you actually have to solder your Teensy, because this is going to be part of this week's lab, then you can refer to the video later if you missed something. Cool. So I'm gonna share my screen with you, and here we go. Okay, I'm gonna. Cool. Perfect. So in your kit you have a lot of different things, and here you should. Can you all see my hand? Yeah. Is it working? Yeah.
Yes.
Cool.
Yep.
Perfect. Thank you. Great. So there are a couple of expensive and less expensive components in your kit. The first, the most important component in your kits is basically the Teensy, and the Teensy that I have here is already assembled. So that's what we're going to do today. We're actually going to put these headers on the Teensy, and we're going to solder them to the Teensy so that we can actually connect the Teensy to the audio shield. So this is where audio is going to come from. So you see that it has an audio jack. So through that audio jack, you're going to be able to plug your headphones, which are part of the kit as well. So this is where audio is going to come from, and basically the Teensy is going to be going on top of this guy, and once the whole thing is assembled, it's going to look like this, basically. And this is what we're going to do today. So once again, the Teensy is basically the computer that we're going to use mostly in this class to synthesize sound. So you can see it's actually very small, and that's why it's great, because it's going to be easy to embed it. And the audio shield is the component we're going to use to actually get audio out of the Teensy. So this is part of your kit. In your kit, you're going to find headers like this one here, and those headers are going to be the ones we're going to solder to the different components we're going to use today. So basically, this is what we're going to do, and you'll see that this is going to involve some cutting and soldering, and so this is also part of your kit. You should have resistors, and they're all 10K resistors, and we'll heavily use them as part of the class. I'm not going to tell you how yet, because there is no point doing that here. Just want to make sure that everyone here has all the components in their kit. Okay, so you should also have this thing here, which is a photoresistor. So it's basically a light sensor, and it's a resistor whose impedance changes in function of the amount of light that you have in a room. You should have something that looks like this. So mine is bigger than yours. The one you have is probably has like a circular shape, and but the connector on the end should be the same, and mine is bigger because they were out of the circular one when I ordered my kit, and also I'm in the instructor, so I get a bigger one. That's how it is. You should have very small buttons like these guys. Okay, so that's also part of what you have in your kit. Okay, and we'll use these buttons to prototype things and activate sound. For example, you have this ultrasound distance sensor, and so these sensors are pretty cool. Basically, they emit ultrasound, and then you can measure the distance between the sensor and whatever you put in front of it. So it's like a continuous distance sensor, and that's also something we're going to use a lot. You should have an accelerometer, and mine is already soldered. So that's something you're gonna do as part of lab number 3. So you don't have to do that this week. But yeah, that's a tiny accelerometer. You should have mountable buttons. So for some reasons, mine are bigger too. Once again, I'm the instructor, so I get the bigger stuff. But yours should be like kind of the same shape, but smaller. It's just that we made a mistake when we ordered those for me. And yours should have the right size and should be smaller than this one. You should have potentiometers. Those are rotary potentiometers, and they come like this. You can actually mount them because they have screws. So if you want to mount them on a panel or something like that, you can do it. And those are the pins that you solder to get a signal out of them. Okay, this is an infrared distance sensor, and it comes in 2 parts. There is the connector, and then there is the infrared sensor here, and so those are for more or less doing the same thing as the ultrasound sensors. Except that they use infrared, and so they will measure the distance between the sensor and whatever you put in front of the sensor, and they're very precise and very good sensors. Then you should have piezo microphones. So those are contact microphones, but you can also use them as sensors. You can glue them on a surface, and for example, I could glue them on this table here, and then I could make sound on the table, and sound would be picked up by these little piezo discs. You should have jack connectors. Those are 1/4-inch TRS, so stereo jack connectors, audio jack connectors, female audio jack connectors, and they are mountable. So if you want to mount them like on a panel or make a stump box with your Teensy, you can do it. Okay, you should have solder, and you should have lots of it. So you can do a lot of soldering this quarter. You should have a spool of black stranded wire and a spool of white stranded wire. Should have electrical tape. Should have a cutter. So mine is different from the one you have in your kit, I believe, but it doesn't matter. And finally, you should have a soldering iron kit. So the one I have here is slightly different from yours, but basically your soldering iron kit should contain a soldering iron, okay, and that's the beast. And that's only for those of you who don't live on campus. If you live on campus, once again, soldering irons were taken off of your kit and made available at Robley Gym, and you have to sign up for slots to go soldering there. And we already sent you an email about that, so you should know everything about this. So I'm not really going to go into more details. If you have questions about this, you can ask them at the end of the class today, and we can give you an answer about this. So that's the soldering iron. Soldering iron also comes with a soldering iron station, which involves a sponge. The sponge is very important. Don't lose it, or you need the sponge if you want to do good soldering. Basically, those two things should be mounted together. I didn't do it because I'm not going to use the soldering iron that has Stanford because it's part of your kits, and it has a little issue. It's not the same kind of plugs that I have here, which is not necessarily a problem, but the main problem is more that here we have 230 volts current, and this expects 110. So if I plug it here, it's probably going to explode. So I'm not going to do it. Okay, in your kits, you should also have something that looks like this. Mine is probably slightly different from yours, but that's a solder sucker. It's super useful for debugging. So for example, if you make a mess and you put solder everywhere in your circuit, you basically push this thing here, and then you have a trigger. And when you pull the trigger, you know, there is like this hose here, and when you pull the trigger, it's just going to suck solder out of the component. So it's super, super useful tool. You have all sorts of other tools as part of your kit that I'm not necessarily going to comment about. There should be a multimeter, and we'll use it a little bit as part of the class, you know, like so that's the multimeter. You should have extra solder. So that's what this is basically. You know, it's just more solder, and it's probably very similar to the one which is part of this pool here. And you should have a USB connector for the Teensy, and I think that's it. Oh no, sorry. You should have jack, quarter-inch male jack connector that we'll use for plugging the piezos, and that's something that we'll do in lab 4. You should have LEDs so that you can make lights. You should have jumper wires, okay? And that's something we're gonna use a lot as part of this class, and I'll show you how that works later today. So jumper wires. And you should have a breadboard. And the breadboard is for prototyping, and that's also something that you're gonna use, well, not this week, but actually next week for next week's lab. Okay, so do you have any questions so far? Because otherwise I will keep going. Any questions? Everyone is happy? Yeah.
Someone in the chat is asking, what do we use for output? Mostly the headphones.
So that's a very, very good question. So on the Teensy audio shield, you have a jack connector, and the jack connector is for headphones, you know, and the headphones that are part of your kit should be completely compatible with this connector here. So just have to plug your headphones to this. So for this week's lab, that's how we're going to make sound. Sound is going to come out of this connector. However, for your final project, and depending on your needs, we might use some of the other outputs which are in the audio shield. So if you take the audio shield and if you go on the back of it, you will see that it says line in here and line out here. And so on the audio shield, you get a stereo output through these pins and a stereo input through these pins. And basically, the female quarter-inch connectors that are part of your kit that we gave you as part of your kit are meant to be connected to these pins. So the pins that I just talked about, you know, like so these pins here at the top. That's something that we will only do like towards the end of the quarter, because once this is all soldered together, you know, like you can't really take it out, you know, like so for now, for prototyping, so for the labs, the audio output we're going to use is going to be this one here. Any other question? Cool. Okay, so I think we're gonna start soldering. So if you go on the course website, and let me go on the course website with you here. So I'm gonna go in 250A. Great. So if you go in the lab kits section, you have a list of all the components which are part of your kit. So I recommend you to have a quick look at it. But if you scroll down and you go in the soldering iron section, there are important safety informations that you should review here, because we really want you to be very careful. You know, soldering irons are slightly dangerous. You can burn yourself. They generate fumes and stuff like that. You know, like so you should read all of these instructions that are here. Okay. So the main things you have to know about soldering iron, like once again, is that they're hot. The tip of soldering iron, like once it's heated, has a temperature which approximate, like 500 or 600 degrees Fahrenheit. So it is very hot. Like if you put it on your finger, it's gonna burn. Like it's gonna be very painful. So you have to be careful with that. The other thing you need to know about soldering irons is that when you use them, you should use them either in a very large room or outside or in a very well ventilated room. Because when we solder, we basically use solder, okay? And even though the solder we gave you is lead free, it has a lot of nasty chemicals in it, and when you melt it, creates smokes, and you're gonna breathe it. Like there is nothing you can do about it. It's not gonna kill you, but if you breathe too much of it, it's probably gonna give you a headache, and it's probably not very healthy too. You should use your soldering iron in a large room, well ventilated, or just do it outside. And the Robley gym on campus applies, of course. Like it's a large room, it's well ventilated, so you should. So that's where you want to use your soldering iron if you are living on campus. Okay. Those are the Stanford instructions that I just like copied and pasted here. Like students should perform no more than 15 minutes a day actively soldering. Okay, so that's in the end, it's your call. That's what they recommend. But like most people in practice who do like electronics, like are gonna solder for more than that. Like those are like very careful rules about soldering. But we really want you to have a look at them. One more thing which is very important to know about soldering is that you really need to use the station, okay? You don't want to put your soldering iron on a table while it's hot, because it might catch on fire depending on what you're doing. So you never put your soldering iron like that, because I don't know if it touches like the table or whatever, it's probably made out of wood, so it might catch on fire, so there is a fire hazard. So you want to always put your soldering iron back on its station, so that it's safe, it's there, and then you can leave it plugged on, like it's fine if it's heating, like it's okay, but never just like put your soldering iron like that, like that's super important. Another thing you should do when you solder is that you should wear safety goggles. The reason for that is because when you melt solder, it's probably going to splash some very, 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 very tiny drops of melted solder. Like, it's not like just going to, right? But you're going to have like super, super small drops, and if one of them goes in one of your eye, it's going to be very painful, and it might be also like very bad for your eye, like so you want to wear safety goggles when you do this. That's important, okay? You don't need to wear a mask. You don't need to, like, I mean, it's not that bad, like just being in a well-ventilated room is fine, like you can, you don't need to wear a mask to do it, but safety goggles are actually important. Cool. So that's for safety. Do you have any questions so far about this? And by the way, guys, I see that Claudia Dorn, who's actually making this soldering thing at the Robley gym, our gym, possible, actually joined us today. Like so I just want to say personally, like, thank you to Claudia for making this possible, because like it really, 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 really helped. Like so thank you, Claudia. Like I see you're here, and so thank you very much. Cool. Okay,
thank you, Romain.
Great, sure. Cool. So we're actually going to start soldering. Like, so for those of you who are at home and have their soldering iron ready, like you can do this as I do it here. For the others, like just watch the recording of the video, like when you'll be at the gym. So the first thing we need to solder in our kit is going to be the Teensy. Okay. So this is the Teensy. So when you take the Teensy out of its sleeve, it doesn't have the headers that we see here. So the first thing you should do is take the headers, okay, which are here, and you should cut them to the size of the Teensy. You know, like so. So basically, I don't remember how many pins there are on the Teensy, but basically, what do you want to do? So I'm sorry, but I only have one Teensy, and it's already pre-soldered. So for that, I'm going to use the audio shield, you know, like which in the end is exactly the same. You know, like so. What you want to do is you want to insert just like this the header in the thing that you're going to solder, and you see that it's too big. Okay, so it means that we need to cut it. And where we're going to cut it is going to be basically on the hole, okay, right next to the last pin, which is connected to the Teensy or the audio shield, okay. And so for that, we're going to use wire cutters. So those wire cutters that I have here are the one that come with your 3D printer. If you don't have these wire cutters, there are also other wire cutters which are coming with your soldering iron kit. So you want to use these cutters to perform this task. Okay. So basically, you measure the size that you need for your header. Okay. And for me, I'm gonna have to cut it here. Okay. And basically, you really let me just do this, you know, and then I'll show you. Sorry, because this is not like super practical, but basically, you really want to cut it on the hole. Okay, you don't want to cut it like on the edge of the hole. You actually want to cut it on the hole because it's going to be easier to cut it there, and it's going to prevent you from doing a bad mistake. Okay, so here I'm just going to cut it. It should be like very easy. You know, like you don't have to push too much on this. Okay, and then basically the header should just like nicely fit into the audio shield, just like that. Okay. So be careful because these headers, like the male header pins here, tend to be sharp. So so like if you like if you scratch them on one of your finger, you might actually cut it. You know, like so be careful when you manipulate those. Okay, cool. So you need to perform this 4 times. Okay, so like because you'll need 2 for the audio shield, and you'll need 2 for the Teensy. And they should have the same size, you know, like, so once you have like one of them, you can just like, you know, copy and paste what you did. Okay, cool. So once you have that, that's going to be like the hardest thing to do in this lab because you're going to have to basically put the headers, and there are pictures of that on the lab. Okay, so you can't really make a mistake, but you're going to have to put the headers on the audio shield, okay? And you're gonna have to do that on both sides. So I only had one header left here, so I'm just gonna put like the shorter one that I have here, but you should put like the full size one, okay? And then you want to flip it and put it upside down on a very stable table, okay? And you want to make sure that once it's on the table, that the male pins are fully perpendicular to the audio shield or to the Teensy. Okay, and so for this first task, you should not do this on the audio shield, but on the Teensy, right? I'm using the audio shield because I don't have any other Teensy left. Okay, like without soldering, you know, like so. So like what I'm showing to you now, you should do it on the Teensy first. Okay, but it just works the same way on the Teensy and on the audio shield. Okay. So first, you put it on the table, and then you make sure that the male pins are perpendicular to the audio shield. And that's very important because if they're not perpendicular, then they're not going to fit in whatever you plug them later. Okay, so you want to be careful with that. Okay, so then we can start soldering. Before you start soldering, the first thing you want to do every time before soldering, you want to take the sponge that comes with the soldering iron in the kit or the sponge at the Rubly Gym, and you want to put water on it, okay? So you want to make sure that the sponge is wet, okay? So I have another sponge here that I'm going to use, and that one is wet. It doesn't have like like to be like super wet. Like you can like squeeze it, and get rid of some of the water in it. But it should be like wet enough so that you can actually clean up the soldering iron tip on the sponge when necessary. And don't neglect that, because you're really going to make a mess if your sponge is not wet. So make sure that the sponge is wet. Okay. So then you can start your soldering iron, and your soldering irons should come with a temperature. Let me show it to you. So you can choose actually the temperature here with this potentiometer. Usually a good soldering temperature is 300 degrees Celsius. Okay, so you want to select 300 degrees Celsius, which is basically something between 5 and 600 degrees Fahrenheit. Okay, so then you start the soldering iron, and then you have to wait for it to heat up. Okay, usually it's probably going to take like 2 to 3 minutes. So here I just turned on my soldering iron, and in the meantime, you can actually prepare solder a little bit. Okay, so my soldering iron is heating up. So while it is heating up, do you have any questions or? So once again, when you do this, you should start with the Teensy. That's in the lab. Like just follow the lab. Okay. I'm doing the audio shield to show you how to solder, okay? But you should start with the Teensy, not the audio shield. If you make a mistake and you start with the audio shield, it's not a big deal, but it will be easier later if you start with the audio shield. Okay, so now I'm going to tilt that a little bit so that you can see everything that is happening, and I'm just checking that everything.
Romain, could you show the Teensy again?
Yes, so this is the Teensy. So the Teensy, you can't really make a mistake. It has a USB port, micro USB port, and then it has this big black square on it and a little button in the back. Okay, and when you get it out of your sleeve, it should not have headers on it. It should just have holes. Okay, and your goal here is to solder the headers to the Teensy. Once again, there are very close pictures in the lab of that. So just go in the lab section if you're not sure about this. Cool. So my soldering iron is warm now. Okay, so once again, you want to be careful with the tip. Now, this thing is at 380 degrees Celsius, so it is super, super hot. Okay. The first thing you want to do is you want to clean up the tip of your soldering iron on the sponge, even if it's clean. Like you always start by doing this. Like you just just clean it up. It should like make some steam a little bit. Because it's hot. Okay, and then the first thing you want to do is you want to put some solder on the tip of the soldering iron. So you bring the solder and you just like press it, and just a little bit, like not more than that, and you see that it's actually smoking now. Okay, and having some solder on the soldering iron tip is going to make soldering much, much, much easier for what we're going to do. Here. Okay. So then what you do is, okay, I'm just going to tilt it a little bit so that you can see things a little bit better here. Maybe I can get it even closer. Okay, just making sure that it's still perpendicular. Okay, so then what you, sorry, now it's out of focus. So maybe, okay, maybe that's the place where I should do it. Sorry about that. I mean, doing this remotely is pretty intense, I must say. So like, that's something that we should do in a lab normally, but you'll see it's pretty easy. Okay. So then what you do is you take the last, like the furthest pin, like you can start from this one or from this one, okay? But you're gonna add solder at the bottom of it, okay? So I'm gonna show it here, and then I'll do it again so that you can see well how it's happening, okay? So I'm just gonna put the soldering iron, on the Teensy like this, and I'm gonna add some solder to the pin, okay? And basically after this operation, it should look like this, okay? So basically, you see that solder is going up a little bit on the male header, you know, and it has this conic shape and it's covering the hole, okay? So this is a nice and good solder solder joint, you know, like yours ideally should look like this, okay? So now that I put solder in here, actually my header is actually not moving anymore. You know, it's already like it's already holding it. So that's why it's important to make sure that when you put the header on the audio shield or the Teensy, it's perpendicular to it. Because if it's not perpendicular and you solder it to the Teensy or the audio shield, then it's going to be too late. You know, like you're going to have to bend it, you know, and it's going to be a pain, you know, like so you want to make sure right from the beginning that you have a 90 degrees angle between the pins and the audio shield or the Teensy. Like once again, you want to start with the Teensy. Okay. So then you do the same thing on the other side. Okay, so I'm gonna do it here. So once again, you know, like my header is too short because I'm out of headers here. And this is also like part of the fun of doing what I'm doing remotely. Okay, just checking that everything is perpendicular. And then you do exactly the same for the neighboring header. You should clean up the tip of your iron every time you know, like you want to do something new, you know, like because it's a good practice and it will make sure that you don't make a mess. Okay, so once it's cleaned up, you put solder again on it just a little bit. Okay, and then you bring your soldering iron to the pin. Then you heat it up and then you put some solder on it, and that's it. Okay, so basically the trick is to touch the pin with the soldering iron so that it heats up the pin, okay? And then you inject solder on the pin as the soldering iron is heating it up, okay? So so you don't want to put the solder on the pin, on the tip, sorry, of the soldering iron, but you want to put it directly on the pin itself, you know, because the soldering iron is only here to heat up the pin, basically, you know, like it's the pin that is actually going to melt solder, okay? Cool. So after this, it should just like, you know, like hold by itself, you know, and then the next step is to make sure that this thing is actually perpendicular. So for this, you're going to use the breadboard. Okay, so this is the breadboard. Okay, and then what you're going to do is you're going to put your Teensy on the breadboard. Okay, and then you're going to make sure that when you put it on the breadboard, it aligns with the holes on the breadboard. Okay, and in my case, it is aligning pretty well. And you know, like just to make sure that it actually aligns, you want to like try to gently press it in the breadboard to make sure. And you want to do this like very, very slowly because you don't want to bend the male pins when you do this. You know, and so in my case, it is perpendicular, you know, like, so it's good, you know, and once again, like, it is very important that these pins are fully perpendicular to the Teensy. Otherwise, it's going to be a problem. Okay. So once you checked that it is actually perpendicular and that you can actually put the Teensy on the breadboard, then you can solder all the other pins, you know, and then you don't want to think too much about it. Right, so you just basically do it. Okay, so I'm cleaning up the soldering iron tip again. Okay, and I'm gonna show that to you. And so start by putting some solder on the tip. Okay, and then I'm adding the solder here, adding the solder here. Okay, and here, and here. Okay, and you know, like, once you get the thing, you know, like, you can actually go pretty quickly with this, you know, like, but take your time, you know, like, just be slow, you know, and eventually you see that all of them are getting this nice conic shape at the bottom. You don't want to put too much solder, because if you put too much solder, it's going to make a mess, you know, and solder might even go on the male pin itself. And if that happens, it's going to be a problem because you're not going to be able to connect your Teensy to the audio shield, okay? So you only want to put solder at the bottom of the tip, okay? So you do this for all the pins on the left side and all the pins on the right side, and then you're done soldering your Teensy. So I'm sure you have questions at this point. So please ask your questions. Maybe not. It's pretty straightforward. Okay, so you know, in normal years, if you completely destroy your Teensy or your audio shield, which happens, it'd be easy for us to give you a new one. And you know, if you're on campus, it will be easy for us to give you a new one. You know, like that's okay. But this year you have to be extra careful of not like screwing this up too much. Like that would, like, especially if you're not in the Bay Area, you know, like, and you cannot come at Stanford to get a new Teensy. So the things you should know and that you should not do that will like potentially screw up everything is, so you see that currently like my solder is really just going on, on the pins here. And there is no solder between two pins, okay? If you put solder between two pins, you're gonna connect them and you don't know what these two pins are. And if you are connecting them, you might actually fry your Teensy depending on what these pins are, because maybe they're not meant to be connected to each other, okay? So, so be very careful to not put solder between two pins. Okay, so just for the sake of the demo, I'm gonna like screw up my Teensy audio shield here just to show you what I'm talking about here. Okay, so I'm gonna put too much solder, and I'm gonna try to solder two pins together, and then I will show you how to fix it if necessary. Okay, so this is very, very bad. You don't want this to happen, okay? Because now these two pins here are actually connected to each other's. And once again, you know, like we don't know what these pins are. So so if you connect them to each other's, you might actually fry the Teensy. So do not do this. So if that happens, how do you fix it? Well, if you can potentially get it out with the soldering iron, just by like pushing on it, that's a good way to solve the problem, you know. And but sometimes it's not too easy to do it. Okay, so in my case, I actually managed to do it. But now there's kind of too much solder, but it's okay. You know, like worst case scenario, you want to try to use the solder sucker that I have here. And the way this works, once again, you know, is that you're going to press this thing here. So you're going to load it, and there is a trigger on it. Okay, and that's the trigger. Okay, and then you're just going to put it super close to where the solder is. Like don't like, you don't have to worry about burning it, you know, because it's not going to burn. It's made for it. Okay, and then you're going to heat things up, and then you're going to press the trigger. Okay, and like now there is no more solder on pin 14. Okay, so it is effective, you know, it is working. In practice, you should not have to do that. I'm just showing it to you so that you know it exists, and that if you screw things up, you can actually fix things. Okay. So after this operation, you will have a fully soldered Teensy, and this is how this is going to look like. Okay, so so that's the Teensy, and you know, like once again, you have to be careful with those male headers because they tend to bend very easily, and they're super sharp. Okay, so once you have the Teensy, then you can actually assemble the audio shield. You know, like once again, you need to assemble the audio shield. The steps are more or less the same. Please read the lab instructions, right? Like you want to read the lab instructions for that. It's super, 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 super important. Like do not like really read them like very carefully, because if you don't do it, you're gonna be in trouble. So so be very careful about that. Okay. So once you have the audio shield and the Teensy, which are ready to be connected to each other's. What you want to do is you actually want to put the Teensy on top of the audio shield, and there is actually an orientation for that. So the USB connector of the Teensy, okay, so that thing here, like the micro USB connector, should be oriented in the same direction as the jack connector on the audio shield. Let me get another audio shield here because that one is kind of weird. So I have many audio shields here. Okay, so that one is more. Oops, sorry, that one is actually upside down. So I'm not gonna do this. Okay. So I'll use that one. So once again, the jack connector should be on the same side as the USB connector. Okay, so jack connector, USB connector on the same side, and then you want to put these two guys on top of each other's. Okay, just like this. Okay, and then you actually want to push the Teensy inside the audio shield. And when you do it, you want to be super careful because once again, it's super easy to actually bend the Teensy male headers. So you want to be like super careful about that. Like you want to go like slowly, like.
Hey, Romain, I'm not sure if you can hear us, but you're currently frozen. Oh, yeah. He's a little more than frozen. He should be back with us in just a minute. I'll go on ahead and just say, since Clara was asking in the chat about micro SD cards, I don't think the Teensy itself, I haven't taken a close look at the 4.0 yet. I've generally worked with 3.2s. I don't think it has a slot for micro SD card, but the audio shield does, which can be really useful because that can be a way for you to get audio files on board to be able to work with without, I think, just having to be stuck with the dedicated like onboard storage, which is very small. Are there any other questions that I can address while we're waiting for Romain to join?
Maybe I'll ask a question, Doug. I think I got a little solder on some of the sides, and so it goes down like about that much. Is that close enough, or should I try clean up the pins a little bit so it's like kind of totally flush?
Hold on, let me put this not in gallery mode. There it is. Can you show that to me again?
You see
might
it?
want to. It's probably fine, but you might want to check and clean it up just a teeny bit. The main thing is just to make sure a teensy bit. You may want to. The thing to really be careful about is just that there's not. too much solder that's getting in the way of things, that there's too much solder so that it's like crossing over to the next pin or something like that. You don't want to accidentally bridge 2 pins.
Okay. It's not bridge. I think it's enough that all the pins are making contact. It just seems like a little far. So I was just curious.
Sure. It's probably fine.
Okay.
And
I have a little exposed guy over here because I broke it a little badly, but I think that'll be okay.
well, if worst comes to worst, for folks who are close to campus, and potentially for folks who are off campus, I mean, we have a lot of extra Teensy 4.0s and audio shields. Mailing them could get tricky, but it's not completely impossible. If you mess up and decide you just want to order one yourself, they're not terribly expensive, especially when compared to like their competitors. Teensy 4.0s you can order from PJRC for $20. Which for a microcontroller, especially for a microcontroller with the features that a Teensy 4.0 has, these are really cheap. I mean, I think an Arduino Uno retails for like 32 or something like that, and that's only got 6 analog pins, whereas the Teensy has like 20 or something. But
nice.
Audio shields are, I think, $15. So, but that looks like it's probably fine, Julie. I was just saying that sort of generally for the class.
Yeah, that's good to know.
Cool. Can also be handy if you guys are interested in doing a project that might require multiple microcontrollers. Like, for example, I have an interface, which we'll talk about in a later class, that's hand controllers, gloves, and each hand has its own microcontroller. So that can be a reason why you might want more than one.
Nice.
Looks like Romain has
I'm sorry, guys,
joined
but
again.
I had a power outage.
Oh no.
Yeah, it's part of the fun. So I'm back. Sorry about that. Hopefully it's not gonna happen again. As I said earlier in this class, I'm actually currently like pretty deep down in the woods. So so like power outages do happen sometimes here. So sorry about that. Okay. So that's where we were. We had the Teensy and the Audio Shield on top of each other's. Like you should not have the jack here. Like that's something that I added later because that's something you're gonna have to do later, but for another lab, okay? So basically your thing should just look like this. So it's basically the Teensy with the Audio Shield under it, okay, and then you just forget about the audio jack here because you don't need that for now. Okay, so there's an orientation for this, right? So once again, you really want to look very, very closely at the pictures in the lab because you can easily solder things upside down. Okay, so you want to be like super careful about that. And let me just show it to you very, very quickly. So once again, the female header, so like the black part of the header should be on the same side as the USB port here, okay? And not the other way around. Otherwise, it's going to be a problem. Same thing for the Audio Shield. On the Audio Shield, you want to have the black part of the header, so the female part of the header on the same side as the audio jack, okay? And then once again, when you connect them to each other's, the USB port should be oriented in the same direction as the audio jack connector on the Audio Shield, okay? And once everything is assembled, it should just look like this, okay? I'm sure Doug answered a lot of questions that you had, but do you have any questions at this point? Good. So So basically, we're now actually done with soldering. So once you're done with soldering, you want to turn off your soldering iron, like turn it off. And that's another potential hazard with soldering iron. It's very easy to forget to turn them off. Like, so do not do that. You want to turn off your soldering iron once you're done using it. And then you want to wait for it, like to cool down a little bit, and it's probably going to take, like maybe 30 minutes or something like that. So don't touch it while it's cooling down, or don't touch the tip of your soldering iron. Another thing that I want to say about soldering iron is that if you don't use them for more than, I would say, I don't know, like 5 minutes, it's actually good to turn them off. Because the problem with soldering iron is that if you keep heating them and there's still solder on the tip of the iron, solder is actually gonna sort of get corroded, and then it's gonna go around the tip, and then it's gonna prevent the tip from working well in the future, like so. So if you want to save your soldering iron tip for a long time, and if you want to be able to reuse it many times, you want to take good care of it. And a way to take good care of it is to actually turn off your soldering iron when you're not using it for more than 5 minutes. Like if you leave your soldering iron on for like an hour without doing anything, then it's gonna get corroded on the tip, and that's not something that you want to have. So yeah, do be careful about that. Yeah. Great. Any questions again, or should we move on? Cool. Okay. So let's move on. So let me share my screen. Let me share my screen again with you. So share screen, and I'm gonna share this. Okay. Cool. So once again, all the informations are in the lab, so if you missed something, you just go in lab 2, and like all the stuff that I just talked about are actually well documented here. Okay, so just follow these steps. Okay, so now before we move on and actually try to make sound with the Teensy, I just want to briefly show you what's on the Teensy. So if you look for Teensy 4.0 pinout on the web, you're gonna get something which is gonna look like this, and that's basically a map of the various pins that you have on the Teensy and that are available to you. So this is something which, and that's also in the lab, there is actually in the link to that in the lab. So please refer to it. So that basically shows you what's on the Teensy and what pin is doing what. And here I want to point out something very, very, very important. So please listen, that's a very important point. So the Teensy inside actually operates at 3.3 volts, and so you can see that starting from the USB port on the right, the third pin is a 3.3 volts pin. So that's where you want to get power from when you have to power something outside of the Teensy, okay? And so the microcontroller on the Teensy operates at 3.3 volts, okay? The thing is, USB, and the Teensy is actually getting power from USB. USB doesn't operate at 3.3 volts, but it operates at 5 volts, okay? And that's why you have a 5 volts pin here, okay? And for some reasons, if you make a mistake, if you connect the 5 volts pin to any other pins on the Teensy without doing anything in between, so if you like take a wire and connect the 5 volts pin to, like, say pin number 22 here, you might actually fry your Teensy, because the Teensy is not meant to be operated at 5 volts. It needs to be operated at 3.3 volts. So you always want to be careful with that 5 volts pin. On the other hand, you'll see in lab 3 that we do use this pin a little bit sometimes, because some of the sensors that we use in the kit, need to be operated at 5 volts and not at 3.3 volts. So sometimes we do use it, but you never want to connect the pin directly to any other pins on the Teensy. Okay. Is that clear or? Okay, cool. So that's one thing very important that I wanted to point out. So once again, there is a link in the lab to this pinout map of the Teensy. So that's something you're going to have to use a lot as part of Music 250A because it allows you to know where things are basically on the Teensy. So it's a very useful resource. Okay. So then after that, before you can actually make and do anything with the Teensy, the first thing you're going to have to do is to install Teensy Duino. And there is a link to Teensy Duino in the lab. I'm just showing it to you here, so that you know what I'm talking about. But just follow the lab, once again, that's what we want you to do here. And Teensy Duino is basically a plugin that goes into the Arduino software, and that allows you to program the Teensy with the Arduino software. So when you're going to do the lab, one of the steps in the lab is going to be to install the Arduino software on your computer, and then to use Teensy Duino to actually customize it so that you get the Arduino software on your computer, and you can program the Teensy with it. So I'm not going to do this here, because there is no point doing that remotely. Please just follow the lab. And if you're having troubles with that, just go to office hours and ask questions. Okay. So sorry, it's just that Zoom is on the way on my screen, and I cannot access to what I wanted to show you. So let me stop screen sharing, and I'm actually going to share my entire screen here right now with you, because I think it makes more sense at this point. Okay, so sharing my entire screen. Cool. So once it will be installed on your computer, it's just gonna look like this. I'm just gonna open a new window and I will put it here. Okay, cool. So this is the Arduino software, and this is what we're gonna use to program the Teensy. Okay, so as a first step, what I recommend you to do, is just to make sure that you can actually program the Teensy with this super simple program that we see here. And that super simple program, is literally doing nothing. Okay, so for that, you're gonna need the USB wire, which is part of your kit. Okay, so I'm getting the USB wire here. Okay, so I get the USB wire, and then you're gonna connect the USB wire to the Teensy. And it's a micro USB cable, so I just connect it to the Teensy, and you want to be very careful with that. Like, you want to be like super gentle, because you'll see it. You get a lot of torque with that wire, and the micro USB port on the Teensy is super fragile. So you want to be like very, very gentle when you actually do this, because otherwise you might actually break the micro USB port on the Teensy, and if that happens, there is not much that you can do. You can try to resolder it, but it's going to be a pain, and in most cases, you probably just need to get a new Teensy. So be very careful when you put the USB wire in it. I know it sounds stupid, but if I tell you, it's because I've seen people breaking their Teensy in their class, not being careful about that. So be careful. Okay. Then you want to connect the other side of the USB wire to your laptop. That's what I'm doing here. Okay, and then your Teensy should be connected to your laptop. Okay, and right, once again, it's the combination of the Teensy and of the audio shield. Cool. So then here in tools, you're gonna have to go in boards, and then you're gonna have to choose between many different options, but you want to choose in Teensy Duino the Teensy 4.0, because you want to tell the Arduino software that you're going to use the Teensy 4.0 to do what you're doing here. Okay, so here I'm choosing Teensy 4.0 because we have a Teensy 4.0 and not something else. Okay. Then still in tools, you're gonna have to go to port, and in port, you're gonna have to choose the Teensy in there. You know, like in my case, there are multiple options, and I'll just take the first one. Okay, so you have to go once again in tools and then port, and in port you want to select the Teensy just to tell the Arduino software that this is this specific Teensy that you want to program. You know, it's in case there were multiple Teensys connected to the computer, you want to tell the computer that you're actually programming this Teensy. Okay, cool. Then all you have to do is to press the upload button here. Okay, so on the top left corner of the Arduino software, you just want to click on upload, and it's probably going to take like 10 seconds. Okay, and then it's going to open the Teensy loader, which is this little software which comes as part of Teensy Duino. Okay, so if you install Teensy Duino properly, the Teensy loader should come with it. Okay, and then the Teensy loader should, you know, like nothing should like appear in red or orange or whatever. Like everything should look happy, you know. Like and now my Teensy is actually programmed, and I can do something with it. Okay. So as I said, the current program we have here is completely useless. It's not doing anything. So in our case, what we want to do here is actually to make sound. Okay, and how is this going to happen? So sound is going to happen with Faust. You know, like you remember, like we said that. So the first thing we need to do here is actually to go in the Faust IDE, and in the Faust IDE, we want to write a Faust program to actually put in the Teensy. And I'm going to be kind of lazy. I'm just going to go in the lab, and I'm going to take where is it? Yeah, I'm going to go in the lab, and I'm going to go in here. So you're going to have to follow this tutorial on the Faust website, which just does what we want. Okay. And I will take this program here, which is the program that we want to put on the Teensy, and I will just paste it in the IDE. Okay, so what do we have here? You should know, you know, I mean, it's a super simple program. We have a sawtooth oscillator, and the sawtooth oscillator is controlled by a frequency numerical entry. Could be anything, you know, it could be a slider. If you want to use a slider, it's okay too, you know, like it doesn't matter actually. And we also can control the gain of the sawtooth wave oscillator using a gain slider or a numerical entry, whatever, you know, like once again, that doesn't really matter. And I'm smoothing them down so that you don't get clicks when you move them. At this point, you should know about that kind of stuff. Yeah, so I'm going to run it just to be sure. Okay. Great, perfect. So it works. Cool. So then what do? Then you want to go in the truck function of the Faust web IDE. So like export, and then you click on export. And then for platform, you're going to choose Teensy. Okay, and then for architecture, you're going to choose Teensy as well. And there's only one option here, so you can't really make a mistake. Then you want to give it a name, okay? And the name I'm going to give it here is actually important because the name you're going to give it here is the name of the Faust object as it's going to show up in the Arduino interface, okay? So you want to remember the name you put here. You don't want to put like example Faust or test or whatever, you know, like, so here I'm going to give it a nice name, and I'm going to call this Faust sawtooth, for example, okay? So Faust sawtooth.dsp. Then I would click on compile, okay, and it should be pretty quick, okay. And then I'm going to download whatever was generated, okay. So downloading, and here I'm going to get a zip file, and if I open the zip file, I'm going to get two different files, one called Faust sawtooth.cpp, and another one called faustsawtooth.h. Okay, so these two files are the files that actually need to be integrated to your Arduino project so that you can actually get sound out of it. Okay, and so I'm gonna go back to the Arduino IDE. Okay, and what I'm gonna do is I'm gonna save that very simple example on my computer, and so I'm gonna say save as. Okay, and that's the saving window. Okay, and I'm gonna call that 250A, and we're 14. Okay, and I'm gonna save that. Okay, and then what I'm gonna do is I'm gonna open my file browser. And in my file browser, I'm gonna go find the Arduino project that I just created. Okay, and so in my case, I believe it's gonna be an Arduino. Like that. That's gonna vary between people. And here it is, 250A 14. Okay, and then what I'm gonna do is I'm gonna drag and drop these files in the same folder as my 250A dash 14 dash dash 4 dash 14.ino, so my Faust sawtooth files should be in the same folder as this one. Okay, so if you're lost, it's okay. Like, once again, everything is scripted and documented in the lab. So you really cannot be wrong with what I'm telling you here. Okay. Cool. So now after this, the Arduino software is aware of these two files. So it means that we can actually call them in here. So I'm gonna go back to the tutorial here, and I'm just doing this quickly, because once again, it's all documented. So there's no point for me to go into here into too many details. So I'm just going to copy that and I'm going to paste it in the Arduino software. Okay, cool. So what is happening here? So the first thing I'm doing here is I'm including audio.h. And audio.h needs to be included because it's a library. It's the Teensy audio library, and you need to include it in the project if you actually want to get audio working on the Teensy. Okay, so you need it. Then I'm including Faust sawtooth.h. So basically the Faust sawtooth program that we just created. Okay, so basically this Faust sawtooth.h, which is included here, is the same as the one that is here in the same folder as my Arduino project. Okay. Then I'm creating a Faust sawtooth object, okay, and so that's the object, okay, and that's the instantiation of the object itself, okay. And I'm using C++ conventions here where class name has a capital letter and its instantiation has a lowercase letter. You don't have to do that, whatever. It's just that's the way I did it. Okay, then I create an audio output I squared S object, and that's basically our audio output. So we create it here. Then I create an audio control SGTL 5000 object, and that's basically the audio shield. Okay, so this thing here is the audio shield. So whenever we need to perform configurations on the audio shield, we're going to have to call this object, which is the audio shield object. Okay, great. So then what I need to do is I need to connect my Faust sawtooth object to the audio output. For that, I'm going to use audio connections. Okay, so I'm creating two audio connections here, and I'm giving them a name. They need a name, like that's how it is, so so I have patch cord 0, patch cord 1. You can call them like the way you want, like if you want to give them a different name, that's fine. And then the way this works is that I say that basically the first output of Faust sawtooth, so that's 0, that's the first output of Faust sawtooth, is going to be connected to the first input of the output. Okay. And then I'm doing the same thing here for the second input of the output, you know, like, so I'm doing this so that I have audio on the left and on the right. Okay. And Faust sort of 0 is the single output of my Faust program, because if we go back in the Faust IDE, my program here, my Faust program only has one output. Okay. So that's why I'm using 0 twice here, because there is only one output here. So left and right. So in the Arduino world, the setup function needs to be declared in an Arduino program, and basically this function is only called once when the device is connected. So basically, whenever you power the device, the first thing it's going to do is actually call the setup function. Okay, and in the setup function, we're calling this thing, which is audio memory. Just put it there. Don't think about it. I'm not even sure what it's doing exactly, but that's like, it has to be here. Okay, it's part of the Teensy audio library. You know, like, and so you need to allocate to something of memory when you start the audio shield. So just put it here. Don't think about it. Okay. Then you need to activate the audio shield, and that's what this is doing. Okay, so this is enabling, so activating the audio shield. And finally, here, I'm actually setting up the volume of the audio shield jack. Okay, so here you need to put a value between 0 and 1. 1 is the maximum. It's going to be super loud. Don't do it. Okay, and 0 is going to be no sound. So here I'm being very careful, and I'm just putting 0.1. Okay, cool. And then here I have a loop. So basically the loop is going to be repeated over and over again. It's a loop, okay, until I actually disconnect the Teensy and I remove power. And what I'm doing is that I'm basically setting the parameter value for the freak parameter. Okay, so if you go back to the Faust IDE, you can see that there is a freak and a gain parameter. So basically the string, the parameter you have here, the freak parameter, is the same as the one that you have here. Okay. And so what I'm doing here is that I'm actually controlling the freak parameter with random numbers between 50 and 1000. So those are frequencies, right? And so I'm gonna assign random frequencies to the freak parameter between 50 and 1000 using this line here. Okay. Finally, the delay is going to slow these things down so that this line is executed only every 50 milliseconds. Okay, so it's still pretty fast, you know, like, but basically this is going to be the rhythm at which the frequency is going to change. So every 50 milliseconds, I'm going to assign a new frequency to my Teensy. Okay, so I'm going to run that, and then I will open things for questions. You know, because I'm sure you have many questions at this point. So I'm just going to upload this. It's going to take more time than the first time, because now there is a lot of stuff that is actually going to go on the Teensy. Okay, and then you get the headphones. And you need to connect the headphones to the audio jack on the Teensy. So like right here, okay. So I'm connecting my headphones on the audio jack, okay. And you don't want to put the headphones on your ears right away, because you never know what's going to happen, you know. And so actually, I do hear sound. So that you can actually hear it, I'm going to recompile this and just like put volume to 1. Okay, reprogramming the Teensy, and there we go. You should hear this beautiful sound made by the Teensy. And if you find it annoying, the only way to stop it is to unplug the Teensy. Okay, there we go. That's what I did. So you want to be super, super, super careful when you do that, because, you know, like using headphones and programming audio, as Doc said last time, is super. It's a super risky business, you know, because if you're wearing the headphones and you're doing something weird as you're programming audio, then it's just gonna like blow in your ears, and it's gonna be painful and might actually damage them. You know, like so. So the first rule when you do what we do in audio technology is you never put your headphones on. You know, like or you know like maybe you want to put them like this, you know, like or like this, but you don't put them on your ears. You know, like that's super 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 important. And only if you hear like a very like a little sound, you know, like or no sound at all, then you want to check, you know, and put them on your ears. But that's only when you want to do this. Okay. So I'm sorry, I kind of went a little bit fast, you know, like, but I wanted to make sure that I spoke about all these things before the end of the class, you know, and I made it, so that's good. But if you were lost at some point, you know, like you can rewatch the video later, you know, I can, and there is also the lab. But do you have any questions?
I have one question. I know you said like just put it back in your mind and not think about it, but I just want to confirm the number of audio memory, like it's supposed to be 2. We're just supposed to have 2, or that's supposed to be like any number.
So the rule, and I think I tell that in the lab, you know, like the rule is if your Teensy has only an output, then it should be 2. And if it has an input and an output, then it should be 6. That's it. And you don't have to think more about it. Like it's not going to impact whatever happens on the Faust side, you know, like so if you have an audio input and an audio output, you want to put 6 in here. And if you only have an audio output, you want to put 2. And there is a documentation for the Teensy audio library on the web, you know, like, and it tries to tell you what this audio memory thing is doing exactly, but it's not super clear. So just, you know, just go with it. So, but it's not a parameter
Thanks.
you're going to have to change a lot, you know, like, so 2 for output, 6 for inputs and outputs. That's it.
Thank you.
Does that the kind code is not stereo, right?
No, yeah, absolutely. Yeah, that's a good question. So these cords are mono cables or mono cords, right? So it means that literally what we do here is we take the single output of the Faust object and we connect it to the left channel of the output. And that's what 0 here is. It's the left channel of the output. And then we do the same thing for the right channel of the audio output. So out here is really just your audio jack out, okay? And so 0 is for left and 1 is for right. And but these audio connection cords are mono cords. Yeah. So every time you need a new cord and for another channel, you need to create a new patch cord the way I did it here. So yeah. Other questions?
Hey, this is a question just like to confirm something. Is it so like you're just assigning like a variable name for these on the right? Like you could, like the Faust sawtooth, you could name it like cheese, for instance, and then you just is that correct? And then like the same thing with like audio shield, you could name it anything.
Absolutely, yeah. So
Okay.
so this could be cheese, and this could be bread, you know, and then of course you have to change that everywhere in the code after that, you know. But yeah, of course, yeah, you can give it any name, you know, like, and once again, like the name here for Faust sawtooth comes from the export that we did here, right? So basically, Faust sawtooth is just the name of your DSP program, you know. Like, so this is Faust sawtooth.dsp, you know, and that's what's gonna like give the name of the Faust object in the Teensy program here.
Sounds delicious. Thank you.
You're welcome. So So, it's pretty cool because, like, once again, these things are so small and they're so powerful. Like, I mean, making something like this 3 years ago was not really possible, and it's pretty amazing that it's so easy now just to program these things to do embedded audio, and that, like, this thing is completely standalone. Like, whenever you plug it, it starts. It has very little latency compared to a computer, and it sounds good. Like, so. This is a really neat thing to do. I think, at least I always get excited every time I do this. Like, I mean, this is nice. So yeah, all the informations are in the lab. So if you have questions, first read the lab. Like, usually there is not much that can go wrong here, except for the soldering part. Like, which is a little bit more complicated potentially. Like, if you're not sure about what you're gonna do, it's good that you actually solder with a teammate or something like that. Like, even if it's on Zoom, like, maybe it's good to have one of your classmates to be on Zoom at the same time as you're actually soldering at the Robley gym or anywhere else in the world. Because like, if you're not sure about something, it's better to ask. Like, before you actually destroy your Teensy. And those things are fragile. So it's actually easy to destroy them. So if you're not sure, please ask. And be slow about all this. So the lab is assigned. It's on the website, and on the course website there is a new assignment, and the new assignment is just making a sound generator for this. Like, there is no control needed. You just want to make something that when you plug it to USB or to the wall or whatever, like, then it starts making sound, just by itself, and so it's more like an algorithmic composition assignment, and the point is we want you to understand how this all works before we actually start plugging sensors to them. So any more questions, or can we call it a day, at least for me? Cool. So once again, you don't want to wait to sign up for soldering slots at the Robley gym. Please do sign up for them, because there are only three soldering stations. So like, if you want to have a slot, please sign up as soon as possible, so that you can actually submit your assignment on time. So yeah. Great. Well, thanks, guys, and I will see you next time. And once again, if you're not sure about something, feel free to shoot a question, or just send us an email, or go to office hours. Yeah. Thank you.